This is the urine production activity that would have been done in class. We have our blood sample here, which we carefully place into the red bowl to indicate that these substances are in the plasma. We have red blood cells, water, urea, hydrogen ions, bicarbonate ions, and glucose. First, we're going to filter the plasma into the filtrate, or in the renal tubules, represented by the yellow bowl. We start with the glucose and move 75% of it into the filtrate. Now, in a real kidney, filtration, of course, is just done by hydrostatic pressure, pushing the blood against the walls of the vessel. With a more complicated apparatus, we could do that. We could have gravity press the beads against a filter as the blood moves through. However, it would be harder to control how much actually gets through than it is in a real glomerulus. So we have 4, 5, 6, 7, 8, 9, 10, 11, 12 glucose. 3/4 of 12 is 9, so 9 of the glucose go into the filtrate, and for every solute molecule, 1 water molecule will go as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's too much. We just want 9. Okay. Second is the urea, of which we're also going to move 3/4 of it. A simpler way to get the count with larger numbers like this would be to place 3 here and then 1 back into the blood, but make sure you count how many are going into the filtrate because we'll need that much water. So we have 3, 6, 9, 12, 15, 18, 21. I wonder if I missed some. We'll say 21. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Obviously, this would be a lot more fun to do than to watch me doing it. Now, our hydrogen and bicarbonate, we're going to move half of each into the filtrate. And again, water to go with each one. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know there should have been 20, so I'm going to put that 10th one there. 2, 4, 6, 8, 10. And then finally the bicarbonate. One, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. Okay, we have now finished filtration. Notice what has not been filtered, the red blood cells. They wouldn't filter in a real kidney because the holes in the glomerulus are too small. We're not really accurately representing the amount of water in plasma. It actually makes up about 92%. But as you can see, we have lost some. Okay. Our next step is reabsorption. The only substance that we've placed here that we actively want to get back is the glucose. We're going to reabsorb 9 glucose. And 9 water to go with it. Now, why did I not say reabsorb all the glucose? Because I have variants of the sample in which there's an abnormal condition going on in the plasma, and if there were excess glucose, we would have more of it in the urine, and the kidneys might not be able to reabsorb it all. Finally, secretion. The only actual waste that we want to get rid of is the urea. Now, the processing of urea in the real kidney is a bit more complicated. We're basically using it to represent wastes as a whole. We're going to move half of what's left into the filtrate without moving the water, because now we are actively moving just the urea from interstitial fluid into filtrates. 1, 2, 3, 4, 5, and apparently I am missing one. We'll go that way. We also need to secrete in order to balance the pH. The pH of our body fluids is close to, but not quite neutral. It's close enough that for simplicity, we're going to say we want our hydrogen ions to balance equally with our bicarbonate ions. Different conditions in the body can lead to one of them being higher than the other. More often, the hydrogen will be higher because we are producing acid through our metabolism. But occasionally, depending on diet or other conditions, the hydrogen could be lower. Now we want equal numbers of these in the plasma, and any extra of either kind will get secreted. So I'm going to take one of each, put them back into the plasma together. And we've ended up with a pretty closely balanced pH in the body. In this example, we only have to secrete one additional hydrogen. As that is usually the case, urine tends to be lower in pH. Our last stage is the effects of ADH. We're going to secrete different amounts of ADH into our bodies based on the concentration of our body fluids. We're going to represent that with the red blood cells. There are 16 of these. We want to have 2 waters in the plasma for each red blood cell. So far in here we have 2, 4, 6, 8, 10, 12, 14. We want 32. So this is a situation where we would be secreting ADH to make the distal convoluted tubule and collecting duct more permeable to allow that water to be resorbed. We were at 14, so now 16, 18, 20, 22, 24, 26, 28, 30, 32. And finally, this is the urine that will be secreted. You can see there's a fair bit of yellow in it. Urea is what makes urine yellow. And if we compare the amount of water to overall solutes, the urine is usually more concentrated than the plasma.